Students, in this part of the video, we are going to discuss about the properties of dot product of the two vectors. As you know that dot product is nothing but the product of the magnitude of the two vectors with the cosine of the angle between them, and it has to be act along the direction of the first vector. It can be represented easily. In earlier video we learnt about what is the dot product. Once again I am repeating the same here to understand in a right way. Let's say it's a vector, okay, we're calling it as a bar, and we have to take the dot product of other vector with this. Here it is as another vector is a b bar, okay, and we join the two vectors. They are inclined at an angle of theta in between, and we have to multiply these vectors. It can be done by easily just drop a normal from the head of the second vector on the vector A, and you know that here we are resolving the vector b bar into components. Along the y-axis length it is the by, along the x-axis what's this, it is bx. What is the dot product here? Here a bar dot b bar is equal to bx into a. Okay, as you know that by taking the trigonometric ratios, bx can be written as b cos theta. We are putting the values here, and we got a bar dot b bar is equal to ab cos theta, or you can write it as b cos theta into a, or simply it is ba cos theta, or ab cos theta. It is the dot product of the vectors, that is ab cos theta. A bar dot b bar is equal to bx into a. Earlier I mentioned you dot product is the product of the magnitude of the two vectors with the cosine of the angle between them. See this, a is the magnitude of the first vector, b is the magnitude of the second vector, and angle between them is cos theta. Now listen to me, we are talking about the properties. The first property is the dot product of the two vectors is commutative. A simple one. What we can say, the first property, a bar dot b bar is equal to b bar dot a bar. We will get the same results, but ab cos theta is equal to ba cos theta. This is the first property. Okay. The second we are learning, that is the product of dot product of two perpendicular vectors. The dot product of two perpendicular vectors is always equal to 0. Here it can be written as ab cos theta. We said that they are perpendicular. It means what? It's the first vector a bar, and it is the second vector b bar. The angle between them is 90 degree. Then it can be written as a bar dot b bar is equal to ab cos theta. Earlier we learnt. Then the angle between the two is 90 degree. Then you can say it is ab multiplied with cos 90, it is equal to 0. ab multiplied with the 0, it is equal to 0. When the two vectors are perpendicular to each other, the dot product is 0. Earlier we learned that we took the two vectors, that means unit vectors, which are in perpendicular directions, and we mentioned them as what? It's the I cap and it is the j cap. Then we will the same result in the place of the ij. Okay, AB, we put the ij, then you will get ij into cos 90. As you know that cos 90 is equal to 0. Then we will learn one more property. Is the property C. The dot product of two vectors, okay, when they are parallel to each other, what could happen? We'll see. The result is AB cos theta. That means the two vectors, this is the vector A and it is lying over is the vector B. The theta is 0. Okay, then what you get? It is AB into cos 0. It is equal to 1. Okay, then it is equal to sum of the magnitudes. When the two vectors are parallel to each other, the dot product of the two vectors is equal to sum of the magnitudes of the vectors. There is one more property. Thereafter, we are going to learn about the component of the projection of the component of one vector over the other. Students, now we are learning about the projection of one vector along other. The projection of one vector along the other. Actually, it is a very important property while we are solving the problems. In problems, most of the time, he is asked this property. Let's say it's a vector A. Okay, and we have one more vector is the B bar. The two vectors are inclined at an angle of theta. Okay, they are inclined along the angle of theta. We have to take the projection of A along B. Here the subtopic is what? Projection of vector A bar along B bar is the first property. The projection of vector A along B bar. Then how we will do? It is very simple. See this, we are resolving this vector into two perpendicular components. One such component is this, okay, and it is one more. Are you observing? We are resolving vector A bar into two rectangular components. Obviously, it can be shown like this. I am extending this to make the things easier. Okay, and it is 90 degree. Okay, then the component which is opposite to the theta is, okay, is the vector A. It is A sine theta, and this one, it is equal to A cos theta. What's this? This vector A is resolved into two components, one along horizontal and second along vertical. He is asking that component of A along B. This is the component of A along B, that is A cos theta. Here we need to get a cos theta along the direction. What is the direction? Along the direction of b bar. Okay, that means what? The unit vector b bar. Okay, here this is we have to find. As you know that if you take two vectors, the magnitude of the two vectors a bar dot b bar, we have to find this is equal to ab cos theta. Understanding me? A bar dot b bar is equal to ab cos theta, or you can write a cos theta is equal to a bar dot b bar by b. Okay, here in the place of a cos theta, say this, in the place of a cos theta I am substituting a bar dot b bar. Then what I get? What's this? A cos theta is written as a bar dot b bar by b into b cap. It is what? Projection of vector A along B. A cos theta into b cap. It is the needed result. A cos theta b is equal to a bar dot b bar by b into b cap. In other words, you can write like this. We can write further. It can be written further as what? B cap. B cap can be written as what? No. B cap is equal to b bar by b. And put the result there. We'll get the same result. Here actually we need to know a cos theta b cap. It is equal to a bar dot b bar by b into b cap is the projection of vector A along the direction of b bar. Here we got the projection of a bar along b bar. In the same way, now we are going to do the projection of vector b bar along a bar. Okay, we are going to do the same here. Say it is the part B. Now as this, we have the two vectors. It is a bar and we got one more. It's the b bar. They are inclined at an angle of theta. We have to take the projection of b bar along a bar. Here we are resolving this b bar into two perpendicular components. These are the two perpendicular components, and you know that it is by and it is bx, and you know that how to resolve the components. Okay, if you take this one, you will get bx is equal to b cos theta. From where we got? We just constructed a triangle. Okay, it is x and it is a y and it is a vector, and drop a normal and we draw the sine theta. If it is a, I said it is ay, it is ax. Sine theta is equal to ay by a, that is ay is equal to a sine theta. Similarly, cos theta is equal to ax by a, that is ax is equal to a cos theta. Similarly, b is resolved into the components. We get by and as well as the bx. That's why I take the value of the bx as b cos theta. What we are doing? We are taking the projection of the B bar along A bar. Okay, that is B cos theta into direction of the A. We are doing the same thing. It is what we have to find. As you know that I am repeating again and again, A bar dot B bar is equal to AB cos theta, and we need the term B cos theta, that is B cos theta is equal to A bar dot B bar by A. Okay, and we are putting the values here, that is B cos theta A cap is equal to, that is B cos theta is equal to A bar dot B bar by A multiplied with the unit vector along A bar. It is the desired result. Okay, is the projection of B vector along A. In previous topic we learned that projection of A along B. I hope you followed the video very well. To understand this video detailedly, please go to the previous one, which is named as vectors number 4. To understand this concept well, please follow the entire series of vectors. Thank you for watching my video. If you like the video, go for subscription and don't forget to give a like. Students, to understand the topic, that is projection of one vector along the other, in a right way, we are going to solve a problem. The problem goes like this. Find the component of vector A bar, which is equal to 2i cap plus 3j cap, along the other vector B bar is equal to I cap plus j cap. First of all, we have to draw the diagram. Let's take a vector. It is A bar, and we have one more. We said it is, the vector is B bar. The angle of inclination is theta. We need what? The component of A bar, this one, A bar, along the B bar. So we are resolving it into two perpendicular components. Okay, and it is one more. This A has been divided, and you know that it is theta, and it is equal to 90 degree, and B bar, as usually, it is what? Is a component A cos theta, and we have to find A. Students, let's do a problem which depends upon the previous topic, that is projection of one vector along other vector. Let's see. The problem is given like this. Find the component of vector A bar, that is 2i cap plus 3j cap, along the direction of the vector B bar, that is I cap plus j cap. First we have to do a little geometry. I am taking this vector as A bar, okay, and we have one more. That's the vector B bar. Okay, let's say inclined at an angle of theta, and we have to take the projection of A bar along the B bar. That's why we are resolving the vectors into components. We are doing little geometry. I said it is 90. If it is A, immediately it is AY. Then here it could be AX. Okay, as you know that AX is equal to a cos theta. Ax is equal to a cos theta. We are doing the same. We are finding a cos theta along the direction of B. Along the direction of B, we have to find a cos theta. As you know that a bar dot B bar is equal to AB cos theta. A cos theta can be written as what? A bar dot B bar by B. I am substituting in this. It is what we need. That is, in the place of a cos theta, I am putting this value. A bar dot B bar by B bar into B cap. It is the component of A along the direction of B. Okay. Here in problems again, a bar is equal to 2I cap plus 3J cap and B bar is equal to I cap plus J cap. In aerial class we learned that if the two vectors are multiplied, a bar dot B bar, the magnitude can be had as x bx plus ay by. Here in this one it is ax, it is bx and it is ay and it is by. I am putting the values. It is 2 plus 3. It is equal to 5. Because the value of a bar dot B bar is equal to 5. Then we have to find the magnitude of the B. Magnitude of the vector B. What is the vector B? I cap plus J cap under root of 1 square plus 1 square. It is equal to root 2. And we have to find out the unit vector B bar, that is B cap, is equal to B bar by modulus of B. B bar, it is I cap plus J cap. Already we got the magnitude by root 2. We have the value of the A bar dot B bar, modulus of B and B cap. Just we have to insert those values in, and what we get? A cos theta B cap is equal to A bar dot B bar, it is 5 by root 2, okay, multiplied with B cap, it is I cap plus J cap upon root 2. It is 5 by 2 of I cap plus J cap, or 5 by 2 I cap plus 5 by 2 J cap is a component of A vector along B vector. You can do the same if you ask the component of B vector along A vector. That is to follow the same process. Okay, I hope you understand this video. If you find